Live from the Moscone Convention Center in San Francisco, California, it's theCUBE at Oracle OpenWorld 2014. Brought to you by headline sponsor Cisco Systems, with support from NetApp. And now, here are your hosts, John Furrier and Jeff Frick.
Okay, welcome back. We're here live in San Francisco for Oracle OpenWorld. We're inside theCUBE, inside the the Cisco booth here at Oracle OpenWorld 2014. This is CUBE. I'm John Furrier with Jeff Frick, Daniel Bogda, Customer Solutions Architect at Cisco. Been involved in a lot of the EMC world activity with theCUBE, and also at late night discussions talking about technology and customers. Welcome to theCUBE.
Thank you, thanks for having me, guys.
One of the things we love to talk about with VCE over the years, and certainly with the Cisco V-Block and all that discussion is how prefabricated solutions are coming to the market, really high end, enabling a lot of new ways to do things, and certainly your role around Internet of Things here at Cisco is a big part of that. So now the converged systems are in place, the data's being captured. What are some of the things that you're seeing at a very high level being enabled by customers now? So as I start kicking in this new gear, the new functionality, what stuff do you see happening that's emerging for solutions?
There's a couple of things we've seen happen. One of them is you start to see a baseline of technology that keeps kind of rising, and it's a rising foundation, or that rising tide that lifts all boats. So the idea is now that we have things like the V-Block, where we've got converged infrastructure that you can actually order by capacity, instead of having to manage the best practices and pull it back together. It gives us a lot of strength to be able to focus on innovation, on the edges of the technology, and not necessarily on the table stakes. And so what it does is it lets us slowly raise the competency of all the IT shops, of every customer out there, and basically start to build on this new higher foundation of technology. Same thing's happening in IoT right now as well. We're starting to look at the Internet of Everything and the Internet of Things. And it gives us that ability to basically be able to focus now on actual use cases and specifics, instead of worrying about the media, the transmission, basically the technologies that make it happen. It gives us the tools to really start to build on top of that, or a whole new tool set.
So what's the big driver for Internet of Things? Is it just more future-proofing, or is there specific things that you see from a deployment standpoint? Is it existing systems and devices, or is it new things like sensors and whatnot?
Promise is the biggest thing I always look at. It's that promise of technology we've been hearing for years and years. It's now we have the tools and the means to actually start to achieve a lot of that promise as well. So where we talked about the magic of the Internet of Everything, of having your refrigerator be able to talk to the grocery store, to talk to the car, to give you a reminder on the way home from work, we now have the technology. We've got the ubiquitous network. We've got Internet everywhere, and we've got processing power down to the edge now that we can actually put it in all the devices, and we can start to enable those devices to start to communicate between each other. And when we get to machine, that's where all that realm of promise of science fiction of everything really starts to come together and gives us that.
Dan, we were talking yesterday about how we're in a really cool spot right now with the market. And just 5 years ago, even 10 years ago, you had to provision stuff on your own, and the notion of Internet of Things on paper sounds interesting, but it's very complex. So talk about, from your perspective, the advances in things just like provisioning, configuration management, all the little nuances, wiring the gear together, used to be manual. And the shift with cloud and a lot of with virtualization has brought in a whole new level of automation. Can you talk about just the sea change and some of the things that are automated now?
Yeah, I'd say there's probably two big trends that are really emerging. One of them is just the operational cost of keeping up with this technology. So we hit a tipping point back in about 2009 where the operational costs actually exceeded the CapEx charges. So the cost to be able to run technology actually exceeded the cost to be able to acquire it. At that point, we had to start to look at efficiencies and how do we be more efficient about using that technology, how do we get deployed, how do we get people out of those processes so that they can scale better. The other half is that as it starts to grow, we get a comfort level with that technology as well. The difference between the promise and the reality is it's the acceptance. We have to kind of believe in the promise, we have to slowly see the reality catch up to it. We have to learn our lessons, we have to make sure we have the right controls in place. But once we get comfortable with those automated processes by removing people from those steps, that's what really lets us scale and lets these things really get their legs of their own.
I want you to describe and define, what does the word edge of the network mean to you? Because that's been kicked around. It used to be a PC, right, on someone's desk. Yeah. But now the edge is much more connected. We were just talking in the opening segment about what mobile's done and the digital transformation, not just from a marketing and selling stuff, but people are connected, devices and humans. So tie that together for us. What does the edge of the network mean?
I was going to ask, where is that edge really? It's it loops back and around. It's like trying to find a Gordian knot. Where does that end really start? The thing is, now that we're machine to machine, now that we're edge to edge, now we have all this capability and even things like fog computing, where we're starting to put intelligent capacity and processing out into that edge. That edge is getting blurrier and blurrier every step we go. What used to be the end of the internet now actually feeds out into sensor networks. It feeds into new capabilities. And so it gives us a lot of strength, a lot of capability to actually pull it all back around and not have a finite end. It loops back across itself, it loops over again, and basically any device can reach any other device out there. I mean, we can't even really say that the Earth is the boundary anymore. We're even looking at internet routers in space and other technologies where we're saying, you know what, there's this benefit of the network effect of being able to connect devices together and let them build their own strengths together. And so it's even better to not have that end in place.
So Dan, I wonder if you could talk about security, because it feels like we're putting a lot of edge devices out there. It's like the small airport where that's where you want to break into the FAA system. The guys may be sleeping at nowhere airport. I mean, can we both attach all these sensors and these connections to the grid as well as either put the intelligence there, or what are we doing for the security? Because it feels like we're just opening a lot more holes.
That's where we've got a good strength there, because when we look at the internet everything, security is one of those things where when it's applied to any system, it needs to be incorporated in the design in the beginning. You need to be able to secure those endpoints. You need to make sure the right levels of communication happen at the right stages, and the right level of information gets synthesized and processed and brought back up into the data centers. You want to make sure you're not opening those new threat vectors. And so with that, as we start to develop these protocols, as we develop the tools for the edge, and as we start to integrate the technologies at those edge routers or at the edge devices, wherever that edge of the internet is, we've got security as an implication, as something that's a consideration from the beginning. And so we can start to do validation of the device types. We can do things like public key encryption, where we can actually validate via certificates that we've got an authenticated device that's doing the right kind of function. And by knowing what kind of device and what it should be doing, we've got a very constrained behavioral analysis we can do. We can say, is this sensor still sensing, or is it starting to reach out and ask questions? And so we can start to do a lot of things from the network as well. When we have that broad view of everything that's happening out there, it's much easier to find those anomalies. They say the more data you look at and the bigger picture you take, the more patterns start to become occurrences, and they start to become regular occurrences as well. And so it's very easy when you've got that broad spectrum of view to be able to say, here's an anomaly, here's something that shouldn't be happening, or here's a sensor that's just not doing what it should be doing.
So the question that we were talking about, Jeff and I were talking about, is that where is the Internet of Things market evolution? First inning, second inning? I mean, are people proof of concepting it, or is it really part of it? I know in the data center, it's been pretty active. Data center probes have been around for a while, been part of the metering and instrumentation of data centers, power and cooling and whatnot. But now, expanding outside the data center, what's real? What do you see developing that's happening from a real-time standpoint?
You know what, I'd say, I mean, we could still be in the warm-ups early. I mean, there's so much promise in this market, and there's so much potential out there. This is kind of that realization where science fiction, where magic starts to really become marketable products. And when you start to look at a lot of things that are happening, where there's coalescence in the market, where we're starting to agree on what technology should be, what products should be, you'll see small little first mover advantage where there's a lot of opportunity. You see things like the electronic metering initiatives that are happening with the power companies, where they're recognizing that by being able to put a little bit more intelligence all the way to the edge of the household, that we can start to change consumption because we close that feedback loop. And you see a couple of new examples around this. You see things like the active parking systems we're working on in Barcelona, where you've got the ability to actually save everybody some time and actually be able to help them focus on what they're trying to get to. But the thing is, you don't see a consistent approach. You don't see an order me a parking system for Lisbon and several other cities. It's something that comes together kind of a nascent market build right now. And so I'd say we're kind of just forming the team up. We've got the batting order down, and I think we're getting ready to start hitting for the stands.
And I think the thing that we see some moves in the marketplace. With virtualization, when VMware bought Nicira, that was kind of like, oh man, network virtualization, we should be on that. It's a shot heard around the world, as we said on theCUBE. Nest was a big shot heard around the world. People can look at Nest and go, okay, I get it. A reasoning like device at the home.
That's actually a great example. So Nest, I think, is one of those, it's also an industry changer. So they've been able to take that first move advantage. They've also been able to leverage that technology to basically change that industry. And when you see that industry get changed like that, I think that's where things really open up. That's where you start to see the other competitors realize that there's a new way of doing business and they need to catch up. And so I think you'll see a lot of the other vendors, and we're starting to have some of these conversations already, but how do we start to leverage our portfolio of technologies, their strengths of a market of product and manufacturing, everything else, and how do we put those together, basically leverage these existing verticals as well as all this new enabling technology to go with it.
So I got to ask you, I'm going to get your perspective on this, might be a little outside the scope of your current job, but put your industry hat on, put your geek hat on. Things like born in the cloud is a term we hear, big companies coming out of the woodwork, talk about Nest as a great example, but DropCam was an innovation that was not about the camera, it was about the cloud. So they're classic DevOps, born in the cloud kind of company. So what is the role of the cloud vis-a-vis the Internet of Things and other opportunities, and two, how does it relate to an existing business who has a data center? So you're bringing the cloud as a nice playground, if you will, to deploy and incubate some of these new technologies around getting the data, getting the stuff from the edge.
The example I've always used, and one that's kind of helped me to frame cloud, frame internet of everything, is actually looking at like power generation. So it's a critical need for any business. Technology's now become that critical need. And the thing they talk about is when you were in manufacturing early in the 1900s, you had to be able to count on electricity, so you'd invest in your own electricity. You'd buy a generator, you'd invest in all that. But even today, where we're in these modern times, we have data centers that have generators built in, we have buildings that have generators built in, because sometimes the service is so critical, you can't do without it. The cost of protecting it is worth that downtime, or all the potential downtime you'll expose. And so the same thing starts to happen around cloud and around data centers. If you have consistent processing, you need to make sure it's always up. That's where the data center starts to come into your own investment. But the nice thing is the cloud starts to be able to provide kind of, again, that foundation that everybody can build on top of, where it's the same as having electricity right out of the wall. Now we've got technology right out of the internet jack as well. And so you've got a platform we can build on.
It's interesting, the electricity analogy, because it wasn't that many years ago in California here that we had all these rolling brownouts, and a lot of complaints about the infrastructure and the electrical system and really the way that power is traded, and it's not really within the scope of this conversation, but what is that people, if the value of the data is worth more than, I just can't have it down, that all this kind of independent power generation being constructed around data centers is really something that's pretty innovative, right?
My first question always when I was consulting was, what's in that data center is worth protecting? It better be worth more than all the investment, all the trouble, all the operations, because otherwise it's not sustainable. You need to make sure that the investment is something that's part of your cost of doing business, but isn't something that hinders the business, but enables it.
Yeah.
And that's exactly the point. Yeah, we need to be able to rely on a service. Sometimes you need to invest in that service yourself.
And the other thing that's interesting is we often talk about kind of consortiums and standards bodies are not necessarily having this way that they used to have, and a lot of that stuff's being defined by the community in an open source aspect. Yet the Internet of Things, or the industrial internet, depending on whose words you want to use, there is a consortium, and there are standards being developed. I wonder if you can speak to that a little bit. I don't know if you're involved, but there seems to be a lot of good traction within a consortium newly formed to support this Internet of Things.
Yeah, you're starting to see the coalitions form. You're starting to see some critical mass start to get there. And as we talked about, like the Nest example, you also see these kind of new entrants come in and shake up industry also. And that kind of provides a catalyst or a forming mission or a statement for those organizations to really catalyze around. But yes, you're starting to see the foundations. Now the one balance is it's when we start to see the technology and the industries really merge wholly, that's where this technology will really take off. Because now what we've seen is we've seen technology approaches, we've seen industry approaches, and we're starting to see them kind of mediate and balance between each other. Well, we're starting to get to kind of a combined technical solution where we can actually start to build on top of the cloud and see the new way of doing things. The trouble is we too often associate the product with the way or the process, and it's separating those different pieces out and seeing what changes with technology or with technical advances. That's kind of the part that disrupts and then eventually kind of finds that new medium.
What do you think about Oracle OpenWorld this year? What's your take so far? Day 2, actually day 3 to count Sunday, but what's your take so far?
It's great energy, great traffic. We're actually already seeing within the Cisco booth twice the normal foot traffic we would see, and a lot of good conversations as well. There's a lot of new information out here. There's, of course, the Internet of Everything emerging and kind of coming as a new stake, as well as the cloud. The cloud's actually another very strong platform out there that's either defining how on-prem is sold, how off-prem and how new companies are getting into technology, or also starting to enable what that disaster recovery, business continuity, or basically the data anywhere approach is starting to be defined.
What's resonating with people out there around Cisco's message here? I mean, is it the fact that you guys are joint customers? I mean, it's the Silicon Valley Mafia. You got Cisco, Oracle, old school Larry, old school John Chambers. It was still, old dogs, in the Valley compared to the, billionaire Mark Zuckerberg.
It's a little bit of everything, right? It's if you look at Zuckerberg and where they're looking to play, they're playing within the cloud. They're leveraging the internet and all the other technologies that already exist out there. And so I wouldn't say it's so much of that as it's more of its pillars of technology. It's things that have been around for 20 plus years and haven't had to change at their heart because there's certain core services you always have in place. Going back to what I just said about product and process and people, if you separate all those different parts out, you're always going to need a medium to communicate. You're always going to need that means to be able to get data between each other. And you're always need some master record that says this is the final result. This is where everything is stored. This is how I always, how I reconcile all my day.
And data is a big part of that.
Oh, certainly. And data, no matter where it resides, be in transit across the network, being analyzed, secured, being able to cross greater distances, or being able to be sorted, measured, analyzed, and basically interacted with via the.
What are some of the customer things that you see that are kind of categorical patterns that you see across all customers? I mean, obviously Cisco, huge install base. I mean, they have edge routers. We talk about edge of the network. Edge is being changed and redefined. You had guys who had training made their careers with Cisco, but now they're in a transformation. What is that next story for Cisco? What does the customer journey look like? What are some of the things that they're thinking about? Rip and replace, technology refresh, new solutions? What can you share?
I've always looked at it as an evolution. This is something that's always kind of worked me up different steps of the stack as well. So when we started out, we were talking about basic connectivity. We talked about how do we get different systems to communicate. But once we got that established, the next thing was starting to build applications that sat on top of that. And you've seen with Cisco, we've been in a steady application pursuit for a long time. We've had application-oriented architectures going back to the early 2000s. And so with that, what's really changing is it's just the applications and their influence or their interaction with the network. None of these are closed systems, and none of these happen in a vacuum either. There's always some reciprocity between technologies, as well as coherence or alignment between those protocols, between the network and the infrastructure that provides and supports it all. And so that's the biggest thing we see here is essentially that basically network operators, everybody's starting to have more of an application understanding, because if we get down to it, the applications themselves are, one, being more demanding, two, they're starting to be a little bit more involved with actually interactions of the network. So where's an endpoint, where's a customer coming from, what's that data flow look like? I spoke a little bit earlier, when you see enough data, trends start to become patterns, and patterns start to become repeating. And with that, you can start to really predict a lot of things. And so you can see things like the application health score, our new ACI product set, where we actually start to look deep within the buffers, analyze traffic patterns, but also recognize what protocol we're transporting, and be able to affect and understand how we can affect that protocol, both at the ASIC level, all the way up to the application level. Those levels of interaction, or closing that feedback loop between the application and the infrastructure that it runs on, that's one of the key technology benefits or wins we've been able to experience here. And what that's done is it's changed our conversations away from basic connectivity to basically the advanced connectivity. How do I enable this application? How do I put the processing closer to the user and close those feedback loops? And what data really needs to come back up to the
So basically with UCS or whatever we were talking about yesterday is that this idea of service profile is interesting, right? So I don't want to make this sound like a negative comment on Cisco, but you guys have been viewed as plumbers. Connect the gear, the pipes, networking. But you're essentially talking about getting more intelligence into the network. Has always been one of those things. And the debate internally at Cisco, we've heard from many insiders, is should we move up, how do we move up the stack? How far should we move the stack? So, okay, I buy that. This is the new normal. Intelligence in the network, that's metadata, that's security. What things have you seen with intelligence in the network that have been new discoveries and new benefits for customers?
So some of the earliest ones is if you go further back, even at points where we had some of the early viruses that were actually very application based, SQL Slammer, things like that, where they actually exploited application knowledge. Those are some of the first areas where having intelligence in the network became very handy. Where you had adaptive viruses that actually change behavior and emulate an application, by being able to distinguish between the application itself and an intruder, that was one of those key value props, where immediately the platform itself, the network, becomes so much more valuable because of that intelligence. The next steps also we start to see is when we start to incorporate security with application knowledge. So knowing when a client is accessing, if it's accessing from two locations simultaneously, that's an immediate red flag that there's something going wrong with this data. The other things, if you look at a lot of the breaches that have occurred in the news and the press, there's a lot of things that have happened out there where if you look at the behavior, you look at the complete system, it starts to make sense. You start to say, how did they miss this? How did they overlook that? Why did they get this patched? And that's the benefit of having the network and the intelligent network really kind of pull these pieces together, is that because we're that substrate, we can be everything from the cloud to the computer to the internet to the IPS to the firewalls to everything in between, and we can unify all that information. And so we can see when an application is reaching across, we can start to selectively accelerate those applications as well. So a couple things we did around TCP, instead of rewriting a protocol that was 30 years old, via the network we were able to actually increase the efficiency of that protocol and be able to start to increase the efficiencies of organizations as well. The same thing happens in asymmetric instances where we have clients connecting to a data center. We can do things like actually prioritize and proxy that traffic or compress it, but do other things where once we understand what the client's trying to do and what the application's intent is, we can bundle that all together to basically a full network effect and remove a lot of those middle or interim steps.
So data is critical here,
always.
Right? So how does the data fabric look there? So like obviously real time. You guys are not new to real time. I mean, knowing Cisco, being kind of a Cisco geek in my early days, packet inspection is about real-time buffering. Packet, speed of the network, packets come in. You guys have done that. But now taking it to a whole nother level, you have real-time being in the moment. nanoseconds, latency, to having historical data. What do you guys do? What's the fabric look like?
So we've got a couple benefits. One example I bring up all the time is the difference between CPU processing and ASIC processing. So the ability to do that deep packet inspection means that we can look at that packet in a single cycle. We can just let the ASIC take a complete chomp instead of having to take little bites of that packet. And so it lets us process it in one instance, be able to look at it instantly and see what the traffic or what the application is trying to do. That gives us incredible insight. And we can actually start to couple that with a lot of our other network instances. So network functions that we've got virtualized or in physical presence, application understanding via ACI and the application templates, and then as well starting to dig into other things like Hadoop and big data and other areas. We can actually pull more of a data sense to get a bigger picture understanding of what's going on out there. But as we pull these different disparate systems together, we've actually got the architectures to handle each processing speed, as well as the data types themselves. We've got our common platform for UCS, where we can actually start to put big data footprints, and we can start to really drive speed through that as well with SSDs and other technologies in the hard drive space, as well as a lot of flash acceleration. But if you put together the whole portfolio, we've got that range of instantaneous with things like Algo Boost and the Nexus 3000, and then quite a few other technologies as well. So anything from instantaneous to basically cloud enabled and long data.
Okay, so a lot of conversation.
No.
Give us some customer stories. Who are the early adopters? What are they doing? What are you seeing?
So
what's exciting out there?
Some of the best things we're seeing is basically instead of trying to use the network as a complete resource, let's start to use the network as something intelligent like we've been talking about. Let's understand what the applications are doing. Let's also understand what the customers are doing. So a couple of great areas we've looked at is basically be able to put that processing right to the edge. Not having to go back up to the data center, not back up to the cloud to be able to make a decision and wait for translation, for delays, for other things to happen. When we're right there in the moment, what we're seeing is we're starting to see more changes where a device can be intelligent. One example we talked about was buses have a very expensive 3G connection. And so we talked about leveraging the accelerometers in the bus to be able to say if it ever gets in an accident, well, let's turn on that 3G connection. Let's start sending video feeds up. Let's send as much data as we can, because right now the cost of that connection doesn't matter. But in a typical day-to-day situation, we're not going to do that. We're going to save it until we get near Wi-Fi. We're going to do a trickle of data up for just the criticals. How's the engine temperature? What's the oil look like? But if there's a potential issue, where there's a life-threatening issue, or there's a health safety issue, we can start to turn on those other systems, those backup systems, and start to leverage them as an immediate lifeline. We can start to make intelligent decisions just based on the logic of the device and its surroundings. So we don't have to have people process, delay, and actually start to make calls and call 911. Instead, we can be able to say, the bus has had an acceleration issue or deceleration issue. Could be a crash, could be a collision, could just be a failure. And so let's turn on those cameras and see what the situation is inside. Let's look around, let's see the environmentals. Let's assess it very quickly because we have that technology there. But now we've got the ability to make the decision and actually send back the result or the ask instead of flooding out the data or being able to wait for the data to come back.
So is that happening now, that example?
We're starting to pull those examples together. Some of the other ones as well is like within energy. We're actually able to start to make a little bit more intelligent decisions about things like solar panels, be able to realign for clouds. So a lot of new use cases. You'll see customers start to announce kind of how they leverage this technology and what they build with it.
Okay.
But the key is that we're putting a lot of these technologies, taking things like Java, and actually putting it right into our edge router so we can actually allow that analysis and the analytics to occur right there.
And really pushing that intelligence, actionable intelligence with action out.
Exactly, and leveraging a common platform too that's happening within mobile, within cloud, and now it's happening right there at the edge too.
Interesting.
All right, Dan, appreciate you coming to theCUBE. Dan Bogda, Customer Solutions Architect at Cisco. A lot of stuff going on at Cisco, really impressive. Thanks for joining us and sharing the data with the audience here. Big data on theCUBE, we're sharing it with you live in San Francisco. We'll be right back with our next guest after this short break.